Welcome to another lesson where we're going to discuss physics concepts. As you may be aware, it's important that now learners access a lot of literature in physics through the electronic platform. And so these lessons come at no cost at all. And for today, we are going to discuss yet another very important lesson where principles are learned so that we can apply them in physics. Areas I stated that during the study of physics, we interact with a lot of vectors. And at times we are required to actually use vectors to solve physics problems. And basically, mainly we have to use the addition concepts as well as multiplication concepts. So earlier we had discussed how we would add vectors using unit vector notation. And so today we are going to move a step ahead and look at how we can actually use the principles of multiplication of vectors. And so here we go. So as we stated earlier, we said today we're looking at multiplication of vectors. So actually, vectors, for them to be multiplied, we can use several methods, but one of them we're going to look at today is the dot product. So let's assume that we have two vectors represented by A and B as shown here. These are three-dimensional vectors, and they are presented as unit vector notation. So we have these vectors, and so if you are to calculate the vector, the dot product of vectors A and B, we merely multiply their magnitude and then multiply by cos theta. So A dot B is equal to the magnitude of vector A multiplied by the magnitude of vector B, and then cos theta, where cos theta is the angle between two vectors, that is vector A and B. And so the magnitude of vectors A and B can be represented as you merely square each coordinate for the axis, that is for the A-axis you square it, and for the Y-axis you square it, and for the Z-axis you square it. Similarly, for the magnitude of B, you square the coordinate axis for X-axis, the coordinate axis also for Y-axis is squared, and for coordinate axis for actually Z is also squared. So the dot product is commutative, meaning that you can multiply them without following a pattern. So meaning that A dot B is the same as B dot A. Okay, and so we have the component formula which can enable us to solve the dot product of vectors, which are in 3 dimensions. And so what we do, if you are getting actually the solution, or you are calculating the dot product, all you may do is that the axis coordinates, you merely multiply them, and then sum. So for example, A dot B, it means that the A axis coordinate should be multiplied to the B coordinate. Okay, as well, then you add the Y coordinate multiplied by the Y coordinate for B. Also, the A coordinate for Z multiplied by Y and the Z coordinate for B. So this is merely the use of the component formula to get the dot product. It's merely as simple as that. And so also note that the multiplication of perpendicular vectors results into something which is actually 0, because as we stated earlier on, you know that cos 90 is actually 0. And therefore, that's why when you multiply, when you get the two dot product of two vectors, actually what you find is 0. And so we will look at now a question which will enable us to cement the understanding of the concepts that we have illustrated above. For example, if you are told to calculate the dot product of vector A, which is 6i plus 2j plus 10k, and B, which is 12i plus 3j plus 5k. As we stated earlier on, you merely, for you to get the dot product of A and B, you merely multiply the corresponding entries for the coordinates. That is A x bx plus ay times by plus az times bz. And so you merely substitute now the actual figures here. For example, you can substitute 6 multiplied by 12, and then you get the sum, which gives us 128. As simple as that. So this is using the component formula in getting the dot product. So the second part of the question will illustrate now to use the formula where there is an angle. For example, here is the question: calculate the angle between the vectors A and B. So you know the representation of the formula is such that A dot B is equal to the magnitude of vector A times the magnitude of vector B cos theta. And earlier on, this is the same equation actually which we solved up there above here. And so we found that we calculated the dot product of A and B as 28. And so we may now substitute where there is actually A dot B, we substitute it with 128. And so all we need to do now is to get the magnitude of vector A and the magnitude of vector B. As we stated earlier on, all you do is square each coordinate system. So for A, you actually square the coordinate for X, Y, and Z, and you get magnitude of A as the square root of actually 1/4. Similarly, for you to get the magnitude of B, you merely square the entries for each coordinate. That is 12 squared plus 3 squared plus 5 squared. And you get the square root of 178. And so you can substitute. So we said A dot B, we calculated is 128 multiplied by A, the magnitude of A, multiplied by the magnitude of B, cos theta. And so you can make cos theta the subject of the formula, and you note that cos theta will be equal to 0.811. And for you to get the angle, you get the inverse of 0.811, which gives us 35.8. So this is the angle between the the two actually vectors. The perpendicular vectors, as we indicated, the last part of the question is looking at perpendicular vectors. As we studied earlier on, if two vectors are perpendicular, it means that the angle between them is 90, and that means that it will be equal to 0. And therefore, if we use the component formula, we know that if we substitute the first entry, that's 2 times 6 plus 4 times 2 plus 2 times negative d, it gives us actually 0. And therefore, the value of d, if we have to make d the subject formula, it is 10. So this is merely the concept which we have learned on solving equations using the dot product. These are very important concepts because complex problems, when we solve them in physics, we are actually required to use vectors. And these mathematical concepts are very important so that we can be able to solve physics problems without any problems. I hope you have understood the concepts and that when you will be solving now complex problems, it will be very easy for you because you would have developed the concepts on how you can actually use the dot product to solve problems in physics. And so remember to subscribe to my YouTube, and also remember that more lessons have been delivered before. So look at them so that you have a series of development of the concepts, so that as you move on to other new concepts, you'll not find problems. I thank you.